Yes.
Whenever you give me the word, I'll do that.
Yeah, let's just wait maybe 5 moments. People will start popping in.
Great.
Yeah.
Hi, folks. Welcome. We'll get started in a few moments. Good to see you all.
Sure, we have 10 people already.
Super.
I think you can start. Probably there'll be some latecomer too.
All right. Well, greetings all. Joseph Kerski here at your service. I'm so glad that you're with me today. I promised to make this 4-hour session. Just kidding, we don't have 4 hours. Just want to make sure you're on your toes. Informative, useful, fun, and get you thinking about several things. Number one, how you might be able to chart your course, as I've got here on the screen, for geographic information systems in your continuing education and in your future workplace. And number two, to get you think about maps as analytical tools, not just where things are, but why they are where they are, and even more importantly, how we can use spatial thinking and geotechnologies to build a more resilient, more equitable, happier, healthier future, more sustainable future, et cetera. That is really the goal of mapping. Now, since I'm a geographer, oftentimes people send me results of the web maps that they make. And we'll talk about how you can do some of that work today. And I'll say, that's great that you've got your data on the map. The invasive species, the population change, the biomes, the water quality, the graffiti, the historical homes in your community, whatever you're interested in, whatever you're passionate about, the urban greenway, etc. But then I'll also say, and why do I say and? Because the map is not the end all goal. The goal is to build deeper understanding of a certain issue, right, that you're grappling with. The maps are, and the geographic technologies that are behind the maps are enabling tools. So when we, for example, I've been a longtime fan of the Atlas program. I know many of you are in the Atlas program, and I met Dr. Gross, oh gosh, we were both at an opening of the St. Vrain Technical Academy together, probably back in 2008, 2009. And I've been a big fan of the Atlas program ever since. So every semester I'm in Professor Powell's class talking to her students about that geotechnologies, and more about this in a moment, is a meaningful application of technology. It's not using technology for technology's sake. It's focused on building this healthier, happier, more resilient, more sustainable future that we're all seeking. And so it's technology actually being used for good. And one of the other reasons why I love the Atlas program is not only do you think thoughtfully about what technologies you're going to use in your future, but you're choosing wisely and you're thinking about the social implications of those technologies. So that's what we're going to also focus on today. So in sum, I've been a big fan of the Atlas program. I think, in my role as education manager for Environmental Systems Research Institute, more about that in a moment. I promise not to bore you to tears, but the point I'm making here is that in my role, I'm actually working with thousands of universities, schools, technical, tribal, community colleges all around the world. And I'm not going to say this just because I'm a CU grad, hey, go Buffs, but I think that what you're doing in the Atlas program is a great model for other universities. And so I'm kind of bragging about you to other universities from where I go in the face-to-face days of my visiting about 30 to 35 campuses annually, and hopefully getting back to, I'm a geographer, so I love getting out in the field. Now, almost all that work is online, but still bragging about you all and the good work that you're doing. So, kudos to you all for selecting a very good program. I think it's the interdisciplinary, just again, the thoughtful nature of meaningful uses of technology in creative ways is to be commended. So again, saluting you all. The other thing I want you to think about is these kind of big questions for a Tuesday morning, but I think they're important ones. What do we want to see in society? I've already touched on several of these things, but let me go back to another aspect of this. All of the issues that we could probably mention in the chat box here, and feel free to contribute anything to the chat zone about what you're concerned about. All of these issues, from economic, racial, social inequities to climate to natural hazards. We're 2 weeks after a huge natural hazard here in our own community, right, folks? And geographic information systems technology, by the way, was instrumental in helping people to know about the evacuation zones and where to go and what zones were affected, but also in the ongoing mitigation. And so it's being used in our community already. But all of the issues that we talked about, and ranging from those to energy, water, all of the UN Sustainable Development Goals, for example, that probably many of you are familiar with, they all are several things. First of all, they're all spatial. They take place in time and space. So they're temporal and spatial. By the way, since we're talking about space, behind me is my homeland, Western Colorado, Mesa County, FIPS code 08071. Now that's pretty geeky. Anyway, that's a code that we use to bring in data into our GIS, 08 being Colorado, 071 being Mesa County. Anyway, the point is, I love landscapes and getting out there, and I salute you all for, again, choosing the program that you did and in the area that you're in, right? I mean, Colorado, one of the greatest places in the world for looking at changes over space and time and getting out there on the landscape. But all of these issues are spatial. They're complex. They require people from a lot of different disciplines. And one of the encouraging things about web-based geographic technologies nowadays, as I'll explain here in a bit, is that it's much more accessible and approachable than it was many years ago when it was all desktop GIS, when it was, you'd basically have to suspend your operations in the Atlas program and devote the next 2 or 3 years to learning geographic information systems. I mean, that's not an exaggeration. It was an extremely niche sort of technology that only a few people knew how to do in an organization. Let's say the city and county of Boulder. There were 1 or 2 GIS people. Oh, you want some maps? You want some spatial data? Go see those people. They're down the hall and to the right. They're a little geeky and nerdy, but they're really nice people. Go see them. Whereas nowadays, more people in an organization, a government, a nonprofit, a private industry, academia, you being the perfect example of the spreading of geotechnologies, which is exactly what we need to build this more resilient world. Because these issues that I'm talking about are interdisciplinary. We need the economists, we need the sociologists, we need the technology folks, we need the environmental science people, we need coding and computer science people, the architects, et cetera, the zoologists, the botanists, et cetera. We need a diversity of disciplines weighing in on these problems. So they cross disciplinary boundaries is what these problems are. And they're complex, as I mentioned, they're all spatial, and they transcend political boundaries, right? They're not just your city, your state, your country, my country. They transcend all those boundaries. And they also transcend physical boundaries like watersheds, and they're not just one watershed, right? They're not just one valley, they're not just one ecoregion. They transcend all those boundaries. And that's why it's wonderful that we have geotechnologies in the cloud nowadays, with data as services, with spatial analytical tools in the cloud, with the ability to share things, for example, with dashboards and story maps that we'll also talk about, many of which you probably have already seen. And isn't it grand that you have your music in the cloud, right? You have some local music on your device, but you've got these music services, right? You've got Spotify and Amazon Music and Apple Music, et cetera, right? Pandora, et cetera. So you can access ABBA's greatest hits in the cloud. And that was a band, by the way. Anyway, the point is, you've got the music in the cloud. You don't care where it is and what server it's on, as long as you can access it anytime, anywhere, on any device, correct? Same thing with documents. If you're collaborating with a colleague, right, at CU on a paper or on a project, you put documents up there, spreadsheets, word process documents, et cetera, in where? OneDrive, Google Drive, Box.com, Dropbox.com, et cetera, right? So you can collaborate on things and you don't have to be emailing back and forth and working with one document. Well, as wonderful it is as it is to have music and those documents in the cloud, I submit to you all that it's even more wonderful to have this evolution of geotechnologies into the cloud. Now, what are geotechnologies? They're remote sensing, looking at the world from space, aircraft, UAVs, or drones, looking at different spectral bands, infrared, the visible range, et cetera, and picking out information from those different parts of the electromagnetic spectrum. It's also geographic information systems, so spatial analysis, increasingly with web GIS. We still have desktop tools that I'll talk about, but increasingly those desktop tools are connected to the cloud, just like when you're running Microsoft Office, right? It's an app. It's a cloud-based app. And it also includes GPS, global positioning systems, or more broadly, global navigation satellite systems, or GNSS, because other countries also have, a couple of other countries have their own GPS systems in place also to figure out where we are when we collect that tree species that's pine beetle infested, or the historic home, or the number of pedestrians in intersections in our community, et cetera. So those things make up geotechnologies. Now, way back in 2004, the US Department of Labor said, hey, there are 3 hot growing fields for the 21st century: nanotechnologies, biotechnologies, and geotechnologies. And we're firmly anchored in the geotechnologies here. Although, as we'll talk about, geotechnologies are increasingly fed by and connected to other IT trends, artificial intelligence, machine learning, and other things we can talk about, as well as data feeds from the Internet of Things, traffic cams, stream gauges, wildfire perimeters, earthquake monitors, weather stations, et cetera. So it's increasingly connected to these other feeds, which is exactly what we need. Why? Because people want information now, or as near real time as possible, right? Take 2 weeks ago, again, for example, we needed to know what the wildfire perimeter was right now. Having the data of 24 hours later isn't going to be all that helpful. So sure, some data, it's okay to get a timestamp in the past, geologic, formations, et cetera. But increasingly, people want that data now or as near real time as possible. So I just ask you these questions to have you chew on for a moment. You're in a massive amount of educational disruption, right? We all are, students and faculty. With education is going to emerge, right? It's always been reinventing itself since the inception of, educational institutions. And so no different now. Universities are grappling with, okay, how can we remain viable? How can we navigate these hybrid online face-to-face waters going forward and design programs that they're really relevant and applicable to student and the workforce needs, which is exactly why one of the reasons why I admire you all in the Atlas program. Also, I love Atlas because I'm a geographer. I mean, what's not to love about that name? Cool. Anyway, the other thing is geotechnologies are going to continue. We're never going to get to a point where the whys of where don't matter, right? Because all the issues that we just talked about earlier, climate, weather, water, et cetera, have a spatial component. And so we're always going to be looking at the place, but not just where it is, but why it is where it is, and how can we chart a more resilient future. So geotechnologies will continue as well. Now, I'm going to go into a little bit of how to contact me, because I don't intend for this short presentation to be, okay, now go forth and map on and live long and prosper. I'd love to be connected with you all in the Atlas program going forward. I think it's really important, and you probably have heard this from your advisors as well, your professors and others, that it's important to build that professional network. So you're hearing it from me as well. Find someone in academia, Ellen and others. I mean, they could be lifelong collaborators and mentors, but also collaborators with you as you write papers or work on projects in the future. I don't really think about that as an undergraduate, but it's nowadays, even while you're an undergraduate, you can start on this professional network. Find someone in nonprofit, find someone in a government agency, local to international agency. Find someone in private industry like me. Find someone in academia, et cetera. So all sectors of society. And this is how to get a hold of me. I'm on LinkedIn, so feel free to connect with me saying, hey, Joseph, we sort of met during the Atlas presentation, and that'd be great. Also, I'm really passionate about this, and that's, again, why I admire you folks in the Atlas program. We really care about the people and the planet, and I think that's what binds us together. We care about these things, and we want to use technologies in meaningful ways to make a better world. One of the things that I wanted to share, not to bore you to tears, but is my own background, just for maybe a few seconds. But I do this for two main reasons. First of all, I've been really blessed to be in 4 different major sectors of society. Nonprofit, so I was president of the National Council for Geographic Education. I love geography and environmental ed. And in government, so lots of years in science mapping agencies, as you can see here at the top left, NOAA, Census, USGS. I was at the USGS for a long time, from the Cretaceous to the Holocene. Now, that's just a little geo joke, a long period of time. And now private industry, Environmental Systems Research Institute, more about that in a moment. And I also, like your professors that you're interacting with, I love teaching. I love interacting with students. So right now I'm teaching at the University of Denver and at the University of Minnesota, okay, online. But I love interacting with students, and it allows me to test out some of my GIS-based lessons and that sort of thing. So the reason why I share all this is because I want you to see that spatial thinking and geotechnologies can be useful in lots of different sectors of society. And the second reason why I share this is that you can change. You're not stuck with one organization. In my case, going from federal agencies to private industry and also having a toe in academic waters all these years. So it shows those two things. And that's why I wanted you to get from that particular part. Scrolling back up here for a moment, I'm rather passionate about all this. I've got 5,000 videos on my Our Earth channel. So again, space and place, geotechnologies, STEM, science, technology, engineering, and math, and so on. So feel free to use those resources. One of the things that I'm really passionate about is helping people understand the world of spatial data. But before I say any more about that, as much as I think it's important for you to know how to, I've got a spreadsheet, Joseph. How do I map that spreadsheet and then do some spatial analysis on clustering or non-clustering of those points that I'm gathering in the field? Or I want to make a story map that communicates my results of the investigation that I'm that I'm in the midst of, and I want to present that in a series of interactive web maps. How do I do that? All those geotechnology skills are important, but this is the most important tool to me, your brain. As you navigate the waters forward, this is the tool that you want to cultivate, if you know what I mean, right? Your spatially enabled brain. Yeah, the software evolves, right? The tools evolve. We're always going to be wanting to buffer, for example, a stream and make a riparian zone, let's say 100 meters on each side or 50 meters on each side. That's a buffer function. It's a proximity function in a geographic information system. No matter what the software does in the future, we're always going to want to do things like that. We're always going to want to take a spreadsheet of data and map it and then analyze it and communicate about it. So the tools change, but again, keep this one in mind as first and foremost. I promised a little bit of where I work and, okay, why should I listen to Joseph? Well, I'm not the end all be all in this zone, but I think I could be a valuable part of your network. And, likewise, I'll gain a lot from interacting with you all. But my organization, Environmental Systems Research Institute, is all about, as you can see here, if you go to esri.com, climate, racial equity, and how do I, especially in this disruptive business world that we're in right now, how do I structure my business so it's viable and sustainable and meeting people's needs and deals with supply chain issues that we're all encountering right now, et cetera, et cetera. How do I do that with these geotechnology tools? So we're all map geeks, for one thing. We love maps. And I used to work at USGS. You probably have gone hiking with a topographic map in the past, but we used to make those in the section where and thematic maps too, earthquake maps, flood maps, et cetera. So we're kind of map geeks, but we don't see the maps as the end. Remember, the end all. The point is to understand our world better. Now, in the education space where I'm anchored, first of all, I think it's important as you go forward to think about the organization that you're going to be working for. Kind of look and do your homework. You probably heard this from your advisors as well, but I'll just confirm perhaps what they're saying. And that is, do your homework on the organization. There are people in the geotechnology and all of the other worlds that you folks are involved with that are independent consultants, to be sure. And that's a noble thing to pursue. There aren't very many of them. Chances are you're going to be actually working for an organization, a government agency, a nonprofit, a private industry, company. And so do your homework on how can you understand what they're concerned about. In our case, it's education, sustainability, and science. And it's been that way since 1969. So we are actually a pretty old software company. We're older than Google, we're older than Microsoft, we're older than Apple. And the reason why we exist is because people want to be able to understand and grapple with the dynamic planet that is the Earth. It would be a lot easier if we were on Mercury and every so often there'd be a meteorite that hits the planet, but not much else happening. But here on the Earth, we've got 7.5 billion people molding and shaping the Earth for harm, but also for good. And we've got natural forces, as we all know, the Tonga eruption, the wildfire in Boulder County, et cetera, happening. So think about how you can contribute to the organization. In the not too distant past, when I was at the U.S. Geological Survey, for example, hey, Joseph, it would be great to work for the USGS. I'd love to be able to get out in the field and collect data all day. Okay, why should we pay you to go out in the field and collect data? And at Esri, oh, Joseph, it'd be great to work for Esri. I'd love to tinker with GIS and learn more GIS. Well, okay, well, why should we pay you to learn more GIS? What are you going to bring to the organization is my point here. Yes, it's good to have your own personal and professional goals, and you can mesh those into the organization goals once you do your homework and figure out what the organization goals are. But remember, it's really about how you're going to contribute to the organization and therefore why they should offer you that position. So just keep that in mind as you go forward. It's really about the organization. And our team is all about supporting students, faculty, campus administrator types, campus safety, campus mapping of every fiber optic cable, every water line, et cetera. So it's that side, it's the curriculum side, but it's also the campus admin side as well, alumni networks, recruiting, et cetera. Anything that's spatial, that's what we're here for. We also work with schools because we truly believe that, hey, we're going to build the next generation of change agents, which I truly believe you all are in the Atlas program. You're being empowered to be change agents on our planet to make positive change happen. That's the reason why we work with schools as well. That's a bit of a challenge as well, but we're not saying, hey, you need to be using GIS when you're in first grade. No, it's all about, hey, I'm going to learn about ecoregions of Colorado. I want to use geotechnologies to learn about ecoregions and population, et cetera, in Colorado at any age or globally. So I want you to think about that. The other thing I want you to think about is, as an introduction to geotechnologies, you've all seen the JHU COVID dashboard. I mean, it's the most, sadly, the most popular dashboard ever created. And maybe an encouraging word for you students is that you may know this, the Johns Hopkins University grad student that worked on this, in conjunction with some advice from that student's professor, created this. So it actually came from a grad student, which is pretty cool. Now, the application, in this case, a dashboard, an ArcGIS technology, in Esri land, all of our technology, our brand of GIS, if you will, is ArcGIS. There's some interesting geeky history behind why it's called ArcGIS that, if you're interested, I could go into. But so it's kind of like McDonald's. Everything at McDonald's starts with Mc something, or at least a lot of things. At Esri, it's ArcGIS. A lot of our products start with ArcGIS because it's our own brand of GIS. Are there other GISs out there? Sure. And some of them are really quite good. So get the landscape of, using the most appropriate tools for the job. Now, this one, as you can see, and as you probably have seen, everybody with a device has probably seen this at least once on their phone or tablet or laptop. But it's got some graphs in it. It's got an interactive map. Obviously, it's got some lists with some of the grim details. Now, you have access to the same set of tools. So I'm going to show one example of that. And this is something I'm really passionate about, walkable neighborhoods. So every time I'm on work travel, or even for fun, I make it a point to go out there in an urban area, in a small town, in a rural area, and see how walkable things are. I'm really passionate about that. And think about what you could use, what are you really interested in that you could use some of these same tools. So I'm going to talk about 4 interconnected pieces of this ArcGIS platform, this web-based platform. And the first piece is a story map, storymaps.arcgis.com, as you can see here in the URL. You can see the tiny print there in the upper left. So here's a photograph I took in Mitchell, South Dakota. Hey, you can see the Corn Palace in the background. Ooh, it's a pretty cool place. Anyway, is this walkable or not? Would you say, it's walkable or not? Put some notes in the chat box. Let me open the chat box. What do you folks think? Would you say this is walkable on a scale of 1 to 10? How would you rate this? 10 being the most walkable, 1 being totally not walkable at all. Thanks, folks. Wow, Denise Powell's on here. I was just singing her praises a bit ago. Hey, Denise, thanks for being here.
Hi, Joseph.
Hey, thanks for having me. Much appreciated. So I'm working with your awesome community here, and they're ranking the walkability. Yeah, it's okay. There's some cars. They're all stationary. There's no traffic. This is a pretty small town in South Dakota. I was there for the state GIS conference a couple of years back. And there's some pretty decent ramp conditions. If you're in a wheelchair or skateboard or something like that, you can get up and down the ramps and go onto the sidewalk. So I would rank it a little bit toward the more walkable than less walkable. But thinking about, okay, other places, is this walkable? How about this? You probably encountered this. I encounter this all the time in my walkability surveys, but even before I started doing these surveys, right? You got a sidewalk and all of a sudden you're on the street and then you're crossing a railroad track, or there's a big drop off. And so less than desirable, right? And why do communities care about walkable neighborhoods? There's economic reasons, there is safety reasons, there's aesthetic reasons, there's all kinds of reasons why communities are starting to realize, I know we've got this automobile culture, but maybe we need to turn our attention to walkable neighborhoods again for a variety of reasons. Now, this one here in Manitowoc, Wisconsin, I was kind of channeling "The Legend Lives On from the Chippewa on down." That's the wreck of the Edmund Fitzgerald. Not a good song to be singing to yourself about a shipwreck when you're walking on this pier, but that's kind of, in my view, sort of a walkable place. But when the lake level is high, like it was a few years ago, the water is actually sloshing over this pier. So, and there's no railing, as you can see. So maybe that's going to taint my opinion of the walk. This is probably the most most recognizable crosswalk in any place in the world. And for some of you that maybe have actually been to Abbey Road, it's not very walkable, actually. That street, there's no stoplight right there. and there's a little sign that says, you know, watch out for tourists, but there's some high speed traffic, not very walkable actually. And so a couple of other places that I've been have you think about that. So what is walkability? How do we define it? We don't have time to go into all that. This is just one example of a story map that has certain elements in it. One of the elements is a survey. So if I click on this submit survey, it pulls up another part of this ArcGIS GIS platform, and that is rate the walkability of a place you happen to be in. And maybe you're pulling up my story map on your phone and you've got that, oh, click on that survey. And this is just like SurveyMonkey or Google Forms or some other tool that you may have used in the past. But in this case, the advantage here of using Survey123, which is, you can see in the URL, survey123.arcgis.com, it can be crowdsourced. So the end user doesn't even need to know anything about GIS to be able to fill out the survey that you deploy. And crowdsourcing is one of the forces that we'll talk about here in a bit. But another advantage of Survey123 is that it immediately turns that data into a mappable feature, part of a feature layer. In this case, the feature layer is about walkable neighborhoods. So is it friendly or unfriendly? Rate the walkability. You could actually fill out my survey. If you pull up this story map that I'll put in the chat box, I've got a link to it. Where is it, which is, of course, germane to our discussion today. And then do you have a photograph of it? Okay, so I've got a survey inside my story map. Then, as you probably would suspect from being in a geotechnology workshop like we're in today, hey, I've got the results with green is the symbol that I chose. This is my own survey, and it's still open until I, the author of the survey, turned it off. Green for walkable, then the hollow pedestrians for not walkable as deemed by the people filling it out, whether it's me or someone else. In this case, I've got one of those data points. Oh, look at this. I've got some kangaroos on the walk with me. Good on you, mate. She'll be right. The point is, this is crowdsourced, and a geotechnology database, or a geodatabase, in another way you can say that, is that every one of these points or lines, it could be polygons, it could be images on your maps, have intelligence behind them. In other words, they're not just map data floating out in cyberspace. They have a database behind them. And the interconnectivity of that database allows you to say how many walkable points are within Boulder versus Longmont, or et cetera. How many invasive species of type X are within 50 meters of this riparian zone, et cetera. You can ask those kinds of spatial questions. How many census tracts with a median age of 25 or less are within this geographic area? See what I mean? So because of those connected databases, you're allowed, you have the power to ask those kinds of spatial questions. Isn't that spatial? Okay, so I've got a map in there, and then, as I sort of hinted at earlier, I've got a dashboard that is, okay, the same tool as the COVID dashboard that I showed a moment ago. There it is again. But here I've got my walkability dashboard. Okay, well, let me scoot some of these Zoom tools around. Here I've got a couple of elements in my dashboard, as you can see. I've got, let me go ahead and full screen-size this. So here I've got it's being fed by my survey, right? And right now I've got 600 and some odd points inside my dashboard, as you can see here in the up, sort of the right zone. About 3/4 of them deemed pedestrian friendly at the moment, and 17 points added last month. I've got top 3 months for surveys. I've got some other things. I've got a list here, the legend, an image showing what this all means, and then of course the interactive web map. So this is a dashboard. So 2 messages on this. First of all, the connectivity of these tools is very powerful. Here I've connected a dashboard, a story map, a survey, and then that web map that I showed, which is actually also in the dashboard. So 4 pieces of this GIS platform that's cloud enabled. The second powerful message, I think, is that the dashboard, the story map, the survey, and the web map took me about 4 class periods to create, about 4 hours total. We're not talking days, weeks, months to create these things. I'm not going to say that geotechnologies and mapping your data and the things that you folks are concerned about is click, 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 done, and all my problems are solved. remember, this is, first of all, this is the most important tool to develop, your brain. Secondly, we've got a dynamic, very complex Earth here, right? It's no oblate spheroid, for one thing. It's not a perfect sphere, so we've got map projection issues and all kinds of other things that we need to think about. So I want people to be critical of the data, more about that in a moment, but the days of desktop only, very difficult for, let's say, Professor Powell and I to share data with each other because we got physical media, it's too big to email. I mean, there are all these technological barriers. Right now, the main challenge is, what do you want to solve? Do you have the data to solve that problem, or some of the tools available? And how can you get to, what's your end goal? That's the challenge, is figuring out how you're going to use these tools in your own research at Atlas and beyond in the workplace. Because I'm here to tell you that no matter what field you all, or all y'all, as they say in Texas, ustedes, you all, whatever field you go into, from anthropology to literally zoology and everything in between, you're going to be asking the whys of where question at some point, right? I mean, I mentioned supply chain management, health, equity, all kinds of issues. It's spatial in nature, and to use these tools in conjunction with spatial thinking, you're not going to use a paper map. Now, I think it's good for those of you that like to go hiking, and hopefully that's many of you here in Colorado. It's actually good to have a paper, maybe a laminated paper, out in the field. Your safety, your life actually could depend on it, right? At some point, your technology will fail. You won't have cell phone reception. You're not going to have your All Trails app available, right? So it's actually good to be able to have a paper map and know how to interpret it and read the signs on the landscape about, the sun, differences of vegetation in the north facing versus south facing slopes, all those sort of outdoor safety tips. I think it's important. But to solve some of these issues on our planet, where you've got, we had 11 months ago, we have a whole utilities team, as you could probably imagine, here in my organization. Guess what? When the power outages happened in Texas because of the ice storms, we sent a lot of people down there to look at, how are you mapping and managing the utility infrastructure? How can we make sure that this doesn't happen again? Because as you may recall, it was a very serious thing. You've got an infant at home and it's 40 degrees F in your house, not a good situation, right? So all kinds of issues around that. So how do we help utility companies manage that infrastructure? You've got to figure out what the load is, for example, on the utility network at different times of day, at different times of year, with a different, and the population is changing, right? People are moving to Texas. It's like Colorado, it's rapid population increase. So how do we grapple with that? You're not going to be using a set of paper drawings and paper maps. As good as those things are, they're limited, right? You can't change the scale. You can't add real-time data. You can't do this kind of thing that we're talking about. I wish I could get excited about this. But anyway, the point is, geotechnologies are incredibly relevant to our world, okay? Questions, comments at this point? Hopefully you're not saying, Joseph, this is the most boring presentation ever, and I'm just going to go check my email for a while. Hopefully you're saying, gosh, this is incredible that I've got this at my fingertips. And you do actually at CU and in the Atlas program. And then we'll talk about, hey, how do I use these tools after I get out of CU when I don't have ready access to all these tools that you're talking about, Joseph? One of the things I want you to really think about closely is, let's say we go into arcgis.com. So I went to arcgis.com and I said, start a new map. Now notice in the upper right, I'm not signed into anything. It's just still says sign in. So I'm going to show you that, there's some things you can do that you don't even require signing in. Now, why would I sign into this ArcGIS system, Joseph? Well, if I want to save something, think of Google Drive. If you want to look at documents, you kind of have to, you want to park documents up there, you have to have a named user and as a part of the account. Same thing with this web-based platform, but there are things you can do without even signing in. So for example, here, I've said, okay, start a new map, and I'm going to search for popular demographics. And then one of the layers that I get is popular demographics in the USA based on the American Community Survey. Could we look at 2020 census data from the decennial? Yes, we could. In the interest of time, I'll just look at popular demographics. So I've got popular demographics, and I've got a different set of layers in here. And one of the nice things about modern web-based geotechnologies is that oftentimes it's scalable data. So as I zoom in, first of all, I'm going to start at the county level. But as I zoom in, as you can see here on the left, I'm going to get, wow, zip code, tract, census tract, block group, all at my fingertips. And now what I can do is say, you know what, I want to map the county level data, and I'm going to change the style or the symbology. I don't want to just map the location. I want to map, oh, wow, look at all this diversity index. I've got the median age, the median income. Oh my goodness gracious, at my fingertips all here. I'm going to look at median age just because it's a fascinating data set to look at and lots of things that go into a median age, right? So I'm going to say, I want to map it. I'm just going to take the default. Can I override these color schemes and the number of classes and the number of categories? Yes. Why would I want to do that? Because maps are powerful tools at your fingertips. So use them wisely. You're influencing your end user's perception of a phenomenon based on the colors you use, the map projection, the classes, equal area, equal interval, standard deviation, natural breaks, however you classify the data, right? So use thoughtfulness when you're creating these, but just taking the defaults for right here, I can see that, wow, I've got an interesting pattern. I've got the Great Plains showing up in this, dark. Okay, why? Because when people move from, Arthur County, Nebraska to the University of Nebraska or the University of Colorado, they're likely not to go back home. They're likely to stay in those larger communities, economic opportunities, et cetera. So the population left behind tends to age, right, over time and becomes older median age. So we've got some counties like Cherry County, Nebraska, with a median age in the upper 40s, and of course you've got Boulder County having the university community there in and high-tech industries and so on and so forth with a younger median age. Fascinating to be able to do this. And this is an illustration of the database that's behind every one of these things. And I could also go to the table of data. So I've got 3,142 counties or county equivalents in the data set. And I could say, well, gosh, wouldn't it be great if I could, total population, just like a spreadsheet, I'm going to sort ascending. So I'm going to get the lowest population. And I've got Loving County, Texas right there, where there are probably more oil wells and rattlesnakes than people. So I'm going to center on selection and zoom down to Loving County. And there it is, just south of Carlsbad, New Mexico, great caving out there. I've been there numerous times. But there's Loving County with a population in 2018 from the American Community Survey of 82. Okay, and then there's that county in Hawaii that you see next. Anyway, the point is, you've got the capability here of doing some powerful things. What if I wanted to filter the data? Ooh, wow. I've got, again, in the old, not too distant past, you had to program all of this. Now, is coding important to modern geotechnologies? If you know a little bit of Python and JavaScript, you can be even more powerful and create some more powerful expressions in here, to be sure. But a lot of this stuff, as you can see, I'm picking from an interface. And I'm going to say, gosh, wouldn't it be grand if I could just scroll down and look at the median age again? And I could say, well, what about a median age is less than 25 by county? Okay, interesting. Apply filter. Okay, now I've got all the counties with a median age of less than 25. Fascinating. Now I've got a couple of these showing up here. Ooh, one of those. Yeah. What if I change the filter and I said, let's scoot some of these windows around. What if I said, well, okay, that might be a little bit harsh. What if I edit that and said 29? Okay, apply filter. Now what do we have? We have a couple more counties in this sort of pale yellow color. Can I change the color? Yes. In the interest of time, I'm not going to do that, but you've got Albany County, Wyoming, right? There's the University of Wyoming up there. There's some ranches around there, but most of the population is actually right there in Laramie. And you've got some counties in Utah, right? Tends to have a younger median age for lots of different reasons than some other places. Some of these counties actually are heavily Native American in South Dakota. I used to teach on the Rosebud Sioux Reservation at Ogallala, the Sinta Gillespie University up there. And is every family Native American up there? No. Does every family have lots of kids? No, but they tend to have larger families. And so there's more kids than the surrounding counties. And so that brings down the median age. And so that's why you get these fascinating patterns that you see. Wow, this is so great. Oh, this is Gary County, Kansas. And you've got the military base. So there's all kinds of reasons, right, why median ages are up or down. And why do we care about that? Remember, what's where, why is it there, and why should we care? Let's say you're starting a business or a service and you're targeting, I don't know, skateboarders. Now, there may be some 80-year-olds that skateboard. Okay, more power to them. But probably your demographic is going to be targeted, or you're going to be thinking about younger people for, I don't know, some cool new skateboard wheels or whatever it is that you're providing a good or a service of. Or if you've got a program that you're managing and you're looking at health variables, you're going to look at certain tracks, neighborhoods, block groups, etc. And maps can be, and these tools that we're talking about right now can be powerful sources for your analysis. Now, another thing is I did this popular demographics, right? Let's look for, maybe some of you are more interested in natural hazards. Oh, current wildfires. Oh, okay. Wow, fascinating to be able to do this at your fingertips. Why? Because we've got this Internet of Things feed, right? And we've got, okay, as of today, this is what's going on here. It's a prescribed fire. Okay, fascinating. Where does the data come from? How do I know if I can trust it? Those are the things I want you to think about. When you're using these mapping tools, you're going to get a whole mountain load, a boat load, a flotilla load. You see where I'm going with this? An armada load of data at your fingertips. Is it going to have the invasive species or the pH or the dissolved solids or the different seasons of the year for water quality, winter conductivity versus summer conductivity, winter sulfate versus summer sulfate? Summer sulfate had me a blast. Summer sulfate happens. Grease. And the point is, you've got a lot of data at your fingertips. Can you trust it? Where did it come from? Is my point. So that's why I've got, I know this sounds super boring, but I've got this data book and blog called Spatial Reserves. And I'm going to put it in the chat box because it might be of value to you. As wonderful as it is to pull up these data sets, I want you to think carefully about, again, anybody is a map maker nowadays, including you all being empowered with using geotechnologies. You're not just a map consumer anymore. Now, in the past, it was, the British Geological Survey, the USGS, the Census Bureau, and, Boulder County land use. I mean, people were empowered to make maps in certain agencies. The general public, by and large, it was almost impossible for us to make anything beyond a sketch map because we didn't have access to those tools. There was no tools for people outside of the sort of the geotech community. Now you and everyone else potentially on the planet can make maps and share those maps and map layers in this, for example, ArcGIS platform. What does that mean? What are the implications? The implications are you need to be critical of the data, right? Since you've got this platform where anybody can contribute to, and literally millions of layers are put in there per day, you need to be careful about looking at the metadata, the information that describes the map or the map layer or the image or whatever you're wanting to use. Sometimes the metadata is lots of good information for you to make a wise and smart decision. Sometimes it's very scanty or non-existent. So again, pay attention to the metadata. I never metadata I didn't like. Ooh, that was a little geopun. That was a very bad geopun. Anyway, the point is, pay attention to that stuff. So when we added, for example, in ArcGIS Online, look, we've got this current wildfires. Where does it come from? I've got a little bit of metadata here about where this stuff actually is generated. How old is it? Is it truly real time? Is it slightly out of date? Every 15 minutes, okay, but data, there's data, what scale was it created at, etc. So you're using this to make an informed decision. And that's the whole focus of this. I know it sounds super dry and boring, but this data blog of mine, every week I've got a new entry with sort of bite-sized, gluten-free nuggets of geospatial information in there, if you know what I mean. So let me show you one of my favorite ones that's a kind of a fun one, but it's also hopefully informative, and that is everyday examples of being critical of data. So in this case, I've got, do a search on George Mason University in Google Maps. Simple Chinese fast food chain. Okay, I thought George Mason was like a serious research institution. Maybe there's a Panda Express in the food court. I don't know why it says that. Anyway, the point is being critical of the data. And look at this one. This was in a this was in a catalog, and there was a map in there. Oops. Now, in fairness, I did write to them, and so did some of my colleagues, and say, you really need to flip this. Maps are not just like a regular image. Orientation matters. I was writing a paper not too long ago, about a year ago, with our Chief Medical Officer, Dr. S.D. Garrity, about the intersection between geography, COVID, mapping, and education. And like you all writing papers, you oftentimes need to know where the source came from. So I was looking up the National Academy of Sciences to find out what their address was. The result was a house in Highlands Ranch, Colorado. That's not the National Academy of Sciences. I've been by there on the road, and I know it's a bit more ostentatious than this house. So why did it come up like that? And by the way, why does Esri have a health team? I think if people wondered about that in the past, when March 2020 rolled around, they didn't wonder about that anymore, right? It's important that we have a health team. We have a chief medical officer that is an internal medicine doctor, and she got so excited about GIS, she said, I want to join Esri. I want to spread these decision-making powerful data sets and tools to beyond my own hospital. So that's why we have a health team. What about this? I've just talked about the Internet of Things, and I know it gets hot in Texas, but this is really hot, really wet, really windy. Look at these temperature readings and other data. The only thing that's normal is the pressure. So if you were making a interpolated surface, which is one of the common things we do with a geotechnology data set, you're making a surface out of points, and you can map it in 3D if you want to. So it could be traffic counts, it could be wildfire hotspots, etc. You would have a big spike at Cleburne, Texas, if you weren't being critical of the data. So even these data feeds, right, can be erroneous for various reasons. And it was online like this for a whole year before that data point was corrected. So I took a screenshot, obviously, before it was corrected. Now this is a fun one. I thought it was a pretty big Fab Four fan. This is non-spatial, but some of these aren't even songs. Penny Lance is in my ear. A Day in the Sky. I mean, some of these aren't even songs. There's someone's misspelled playlist. It's not even an album. So be critical of the data, spatial and non-spatial. But I think the danger in spatial data is people look at this kind of thing and see these data sets and they say, oh, well, Joseph, this is authoritative data. And I can trust that data point is actually right there where it says it is. And if I change the base map, for example, to, I don't know, the imagery hybrid, and then go back here and turn off my popular demographics, and I just have the wildfires on there, how confident am I that it's actually in this spot, X meters, right, from this roadway, 225 meters west of that roadway? Maybe. I think the cautionary note is that maps tend to be believed, right? They look like they're authoritative sources. And remember, everybody is a potential map maker. Some of that crowdsourced and other data from the non-scientific community is actually quite good, right? In part because it's important because the Forest Service, the BLM, the Bureau of Land Management, the Park Service, they don't have field staff like they did way back in the 20th century. Most of those folks had to be pulled into the office because of costs and other reasons, budgets and so on. But the citizen science community collecting data on weather, birds, pine beetle infestation, etc., has contributed vast amounts of information. Much of it is very good. One of my favorite crowdsourced data sets is this OpenStreetMap, which is a crowdsourced base map, mostly created when countries didn't have a national mapping agency and or that data was not available to the general public. People said, we're going to take matters into our own hands and create something called OpenStreetMap, sort of like a Wikipedia for mapping. And this data is actually quite good, and it's vetted, it's reviewed, and so on, and it's being served into this ArcGIS platform, ArcGIS Online in this case. Anyway, the point is, a lot of that crowdsourced data is actually quite good, but be critical of data. Just because it's mapped doesn't mean it's perfect. Remember, we're trying to map a complex world that's an oblate spheroid to begin with, so there's all kinds of cautionary notes, but still, I want you to use these tools and I want you to use these maps, but just be thoughtful about what you're using it for, the scale you're using it for, the time period you're using it for, etc. Okay, so that is the Spatial Reserves blog. Now, another thing I wanted to chat with you all about is what I consider to be some forces that are important as we navigate the waters forward. The awareness for the issues that I talked about at the beginning of this presentation, climate, health, etc., are rising, right? People are now concerned about these things, and they realize they don't always connect it to this geotechnology set of skills, but they realize that they're serious and they need to be addressed. So awareness is at an all-time high, at least in my career, and the enablement of people using some aspect of these tools, even if it's just to find, your grandmother's house, or find your way across campus, or find the store that has X product right now near me, or something like that, or the nearest, the evacuation route, or whatever it is, right? They're at least enabled to use some of those tools, even if they don't really realize that it's geotechnologies operating behind the scenes. Geotechnologies is kind of like an elevator. You push buttons and you expect something to happen. Think about this: the food you ate yesterday, supply chain, that's heavily driven by geotechnologies. The electricity that's running your computer, the power companies are using geotechnologies, as I talked about earlier. I mean, RTD in Boulder, right? I mean, the transportation network. Geotechnologies is really enabling modern society to happen. It's operating behind the scenes, and it's oftentimes difficult to sort of pinpoint and take a hold of. But it is fundamental to not only operating, but understanding our world. And again, I think it's going to be an important tool as you go forward. And this central hexagon here, the geotechnologies themselves having migrated into this cloud-based environment, what does that mean to you and I? It means that you all in the Atlas program don't have to spend the next, X years learning to use this stuff. There are plenty of tutorials that I and my team and others have written, video form, lesson form, slides, to, hey, I want to map a spreadsheet. How do I do that? How do I change the symbology like Joseph did in ArcGIS Online? There's a, much of this is intuitive, but when you get stuck, it's like, okay, I need to, like fixing your sink at home. Oh, I need to go to Bob's sink video and watch that a couple of times. There's resources to get unstuck, is the point. And then citizen science, I've talked about that a bit. The nice thing about these citizen science organizations that they're using these tools now it can map the birds or the pine beetle infestation, et cetera, a lot more readily. I mean, you all use a fitness app, right? Or many of you do. That's all enabled by geotechnologies, right? We can't have those interactive maps. Oh, I can, if I go around the block one more time, I can get 5 miles instead of 4.9, et cetera. And then finally, storytelling. This whole presentation, I promised to put this in the chat box because I'm going to have a lot of content that I'm not going to be able to cover today. But this whole thing is a story map, right? I'm presenting this as a story map because I want you to see how this technology came to be. And I'm not going to go into it all right here, but the point is, this is a nice way for me to present the content. For example, you can embed videos in a story map. So here I've got, a sort of emerging between what's underground and what's overground. So you can be walking around with your phone and look at what's underground, utilities, et cetera, with a partner of Esri's called Augmented Reality GIS. So I wrote an essay not too long ago about, hey, if I'm a student, how can I use this stuff? I want to map stuff on campus. How do I see that on my phone? So this is a story map. Now, a couple of trends here as we sort of get to the end of our time together, but 3D, it makes sense. We've got a 3D world. It makes sense that we've got 3D tools. Okay, we've had 3D visualization for quite some time, but now you actually have 3D analytical tools at your fingertips. The joining, or at least the touching of building information management, computer-aided drafting, and the architecture, engineering, and construction worlds with GIS is important. Let's say, take one example, CU Boulder. They've got some sort of emergency plan, right? If there's some sort of major weather event that happens at 3 p.m. on a Friday, we've got to merge. And in order for that thing to happen, the outside mapped data on our campus with the interior spaces, where are the emergency exits, where are the emergency shelters, where are the students at 3 p.m. on a Friday. Of course, that changes every semester. And of course, it changes with, in-person, hybrid, et cetera, right? It all changes. So you've got to be able to map that stuff in near real time as possible. And in order to build all that, we have to have this, hey, all the people mapping interior spaces for years and the people that were mapping exterior spaces, biomes, census tracts, wildfires, et cetera, were sort of two different worlds. And now with ArcGIS Urban, City Engine, and a couple of other things, a couple of other tools that you also have at your fingertips. You can merge at least in part those two worlds. And then I mentioned this earlier, but the ability to ingest some of these real-time data feeds is hugely important going forward if we're really going to understand and be able to react or plan for various scenarios. We've got to be able to have the connection to stream gauging stations, wildfire perimeters, traffic counts, etc. Enterprise and WebGIS. What I mean by that is that I think there's a few people in an organization that need to know a lot about geotechnologies. To build the geodatabases, to actually create all these web maps requires, Jupyter notebooks, Python, JavaScript, coders. If you're interested in that side, I know some of you are, then there's lots of opportunity because most people in GIS came into it like me. They were planners or environmental scientists or geographers, and they love maps. They've taken a few computer science courses and they know how to build some simple scripts, but they're not the people that are enabling the new tools to be developed. So we need those folks as well. But I think a lot of people in an organization need to know a little bit about geotechnologies. And I don't know where you fall in that sort of spectrum. I think all the Atlas people, since you love data, right? You want to make a positive contribution to the planet, and you want to use appropriate technologies in meaningful ways to make smarter decisions. I think you need to at least be in some part of that spectrum where you need to maybe a few toes into the swimming pool of geotechnologies. It may not be your whole job. It may be a part of it, maybe a tool on your tool belt, but some familiarity with this, I think, is going to be helpful as you be a change agent in the future. And also, I think it could help you get that position at EPA or Colorado DNR or Boulder County Planning or wherever you want to work, okay? And then finally, artificial intelligence and machine learning is becoming very big in GIS. I mean, I already mentioned the Texas utility example. Picture this though, if you've got let's say a video, and I don't know how well this will stream over, but let's say I was at South Dakota State University at the end of one of the winters there. You can see how much snow is still sitting around. But let's say everything in this video could be captured. That's the condition of the pavement. That's a tree species. It's in this condition. Here's the soil moisture. Here is the pavement condition. Here are the number of vehicles. Here's the condition of that building. If every single one of those things could be automatically gathered, wow, wouldn't that be fascinating? And that's what we're getting to. Many of the entry-level GIS positions in the past were a little bit dry, shall we say, collecting all the parcels, all the fire hydrants, all the light poles, all the soil moisture in an area. And that's important work, and some of it still is done manually within a GIS. But increasingly, you're getting these ingestions of AI and machine learning, even from a simple video, being able to capture all of that immediately. So then, those jobs are more on the analytical side now. It's like, okay, I've got all this data, I got to make sense of it all, which is a big challenge too. So finally, I'm going to skip down to what I feel are the top 5 skills for you all as you use these tools going forward. And first of all, and this is another reason why I love the Atlas program, you're being encouraged to ask questions. You're not just being lectured to. You've got a whole wide variety of instructional scenarios. You're hands-on learners. That's what I love about geotechnologies. It's a hands-on kind of environment. You're making maps, you're doing analysis, you're publishing into Story Map, you're making a dashboard, etc. And so being curious about the world, I think, is the most important skill going forward, folks. It leads you to be tenacious with software, with problems. You want to stick with it until you get at least some of it understood in a better way. It leads to additional questions, and the cycle continues. But being able to work with data, I mentioned this earlier. Probably some of you are bored with me talking about data, but data is so important, right? Because the results are as good as the data you put into it. So that Spatial Reserve data blog, for example, and also intertwined with that, I wish we had more time to talk about this, but the ethical implications of what you're doing, which again was one of the reasons why I love the Atlas program. You're thinking about the ethical implications of technologies. And geotechnologies is being used by the Jane Goodall Elephant Foundation, by the Deforest Action people, by all kinds of organizations around the world, including right here at home, right, by Boulder County City Planning and Boulder City, the City of Boulder Planning, and state of Colorado DNR. It's local to global. So there's lots of ethical considerations of this, and we could talk more about that. But again, kind of intertwined with how you're going to present the data and what scale you're going to use and the map projection you're going to use and all of that sort of thing. And then also know some of these geotechnical and some of these skills that I mentioned earlier. Again, think about where you want to fall in this. How many toes into the geotechnology swimming pool do you want to put in there? And it's a lifelong process, right, folks? None of us know all of chemistry or all of computer science or all of geotechnologies. It's what problem that you're working on, how could it be enhanced by some of the things that we're talking about today? And then also adaptability. In my career, the most valued experiences that I've had are some of my international experiences. I know many of you are probably from far-flung places around the globe, and that's awesome. For those of you that have, maybe been in Colorado or certain branch out, take an opportunity where you're really stretched beyond your comfort zone. You're working with different cultures around the world, and that's just great opportunities to do that. And also, on a related note, and a bit easier to do, is at a conference, go to a track that's not even in your own wheelhouse. So at a recent geography conference, I went to the social work track, and I learned a lot. I met some new people. I learned about their methods, what keeps them up at night, you know what I mean, that kind of stuff. And so I just encourage you to kind of step outside your own. And that's what I love about Atlas is that you've got this amazing mixture of these wonderful folks with all kinds of different backgrounds and interests. And then finally have this good communications. Your city manager, your constituents, your board of directors, your et cetera, is going to ask you what you're contributing to the organization because there's a board meeting that, board down the hall or on Zoom or Teams or something like that. And you've got to present in 30 seconds why your position matters and what value you're bringing. Have those speeches ready to go. And also, your 5-minute, your 30-minute, your 1-hour training that you're doing for colleagues, have that sort of down and morph it as the tools change and as your, mission changes. I truly believe that this decade will be exciting for geotechnologies. I mean, we've got a lot of problems, but we've got good, smart people like you all. We've got some good tools. We've got some good data. And you have a key role in achieving this more sustainable, happier, healthier, more equitable world. So again, I salute you all. Again, the goal is not to, stop at learning more geotech. We want to make smarter decisions. We desperately need to make smarter decisions. And so, again, I salute you all and wondering, where you think this location is that I'm taking a picture of right here. Questions, comments, issues, concerns? I like Suipi's pictures, like this energy coming out of the head. Fascinating. Anyway, thanks for sharing. Folks, how was that? Again, more we could say, but I wanted to turn it over to you all to see if you've got any concerns or something you're curious about. I'm going to share a couple of things while you folks are thinking. Forgive my big fingers here. I only have one monitor at the moment. But I would encourage you, one way to move forward with this is take one of our massive open online courses. They're free. You get connected with a cohort going through those courses. One's on cartography, one's on spatial analysis, one's on building web apps like those dashboards and story maps, fairly decent variety of things. One's on business applications, and they're free. They're about 5 or 6 weeks long. You can even just tap into one, an hour a week and just kind of get a little taste for some of these things and go through a couple of the lessons. That's one way of kind of moving forward with this. Well, I'm here for you all. If you've got any concerns or questions, thanks for having me, and appreciate you sharing at least a little part of your day with me. And I'm hoping that gets you thinking, I could actually use this for something in Atlas or beyond.
Yes, thank you.
Hi, Joseph. It's not a question. Hello. Thank you again so much for the
Hi,
presentation.
Rishi. Yeah.
So this is particularly interesting to me because right now I'm at Atlas. I work on augmented and virtual reality research, but then my undergraduate degree was in civil engineering. So I've worked on projects involving GIS, urban science, and frankly, this was the most enthusiastic presentation of that I've seen. So, and I think maybe if I'd seen this 4 years ago, I might not have been doing what I'm doing right now. I might have just gone this route entirely. But then, yeah, like it's given me a lot to think about, and maybe wondering if I can actually integrate something that I've been trying to run away from to the next step. But then this was super interesting. Thank you so much for your time.
Well, thanks for the comment. You know, and I meant what I said about the CAD, BIM, AEC, engineering linked to GIS now. We desperately need people with your background and interest in this field. You know, I'm in education, so I'm working with, you know, schools of engineering in various universities, for example, trying to see how they could integrate this into their program. Also, you know, a tool to take a look at, and I'll put it in the chat box here. I mentioned it earlier, but it's kind of in passing. ArcGIS Urban. It's a 3D modeling tool, all in the cloud, nothing to install, but you can do things like, hey, if I construct this building here next to this park, how much of that park is going to be in shadow at different times of day and at different seasons of the year based on latitude and longitude, that kind of stuff. Or if I offset that building slightly and let's build a model, kind of like SketchUp meets GIS. I'm going to offset the building and I'm going to slant it a bit. Okay, now how much of that park is in shadow, and so on. Other things that you can do with 2D and 3D. But ArcGIS Urban is a really great tool to maybe get started with. And there's, again, you know, tutorials and how do you get started. And by the way, I think I mentioned this earlier, but you folks at CU Boulder, you've got a site license for all this stuff that I've talked about, which means that you have access to all the tools that I talked about. ArcGIS Pro, which is a desktop connected to the cloud, gives you about 1,000 different analytical tools. ArcGIS Online, which I was showing earlier, has about 50 or so analytical tools in it. ArcGIS Urban, there's something called Insights. This is sort of like Tableau meets GIS. There's Business Analyst Web, which if you're on the business side of things, you want to look at, you know, consumer preferences. Who owns more than 2 dogs and more than 2 cats? And where are the existing pet kennels? And where should I cite one of these? You know, that kind of stuff. There's a lot of data in there, even if you're not using it for business purposes, just the consumer preference stuff alone. Who's contributed to an environmental cause? And where's all that data come from? A lot of that comes from credit card purchases. So it's not from a census, you know, we actually buy it from credit card gathering data. You know, it's not individual like what you or I buy. It's all aggregated, but it's just an amazing set of data, and for multiple countries. So it's not just USA. Now, can you get sub-neighborhood data for, you know, North Korea? No, basically, no, you can't, right? Certain places around the world, the data is not gathered, or it's copyrighted, or it's behind a fee wall. Or somehow we couldn't get it into that product. But there's a lot of data at various kinds of, you know, administrative and geographic areas for many places around the world. And that's another tool that I wanted to mention. Anyway, and so then you say, well, Joseph, someday I'm going to be out of CU. How do I keep using these tools? There's a personal use license for this. If you're not connected to an organization that has already bought it, there's a personal use license. There's for $100. You have access to, you can't run your own mapping company with it. You can, it's for teaching and learning. There's also developer.arcgis.com where you can get a free account to make story maps and dashboards and do the ArcGIS Online stuff that I was talking about, totally free. And you may say, well, Joseph, why do we have to charge for this stuff? Why can't this all be free? Well, here's the reason. Because we got to have software engineers and others to create the tools that people are asking for. And we have to pay those people, and they're very good people. And we'd love to have, you know, some of you consider working for our organization at some point. We've got about 8,000 employees. And some of them are, you know, when you're thinking about future jobs and where to work, there's some pretty cool locations for Esri offices. Zurich, Beijing, Melbourne, good on you, mates. She'll be right. Esri East Africa, there's Esri Japan, there's Esri France, boom. Anyway, the point is, there's also business partners. There's about 300 business partners that take our technology and serve utilities or serve planning agencies or serve, there's one that actually serves schools, school bus routing, what schools to open, what schools to close. So they just serve the K-12 school market. Anyway, there's some business partners that you might be interested in also.
Okay, but yeah, thank you so much once again. I will look into all of this, and I will definitely reach out to talk more about this soon. But yeah.
Very good, folks. Well, again, appreciate the attention and the questions, and I wish you all the best. I know that you will be the change agents that we so desperately need. So all best wishes to you all.